So sometimes this isn't easy. Sometimes we look at these and it's actually quite difficult. So let's look at one that is challenging. Sometimes we do this the easy way and sometimes we do it the hard way. If I look at this table of values, your instinct might be to go, okay, the initial value is 4. But that's not true. That is not correct. And the reason it's not correct is because it's not paired with 0. So what do we have to do then? Well, since 0 isn't on the table, let's put it there. And that is the trick to a question like this, where we'd say, okay, I'm going to erase this for a sec, and I'm just going to take a picture of this. And we're going to put that below. And then I can highlight like that. I could even say, this would be our first idea. But it's the wrong idea. So let's take a look at what we can do. And what we have to do is we have to work backwards. Wow, that's a big old picture. We have to work backwards, and since 0 isn't on the table, we need to say, well, if 0 were on the table, what would it look like? And so what I kind of like to do is I kind of like to think, okay, there are my x's, there are my y's, and I actually just kind of like to say, okay, the thing I wish were on this table were 0 here. Because if 0 were here on the table, then I would know what the initial value is, because that would be the spot where the initial value is. And if you're lucky, the table will follow a nice pattern. Sometimes they won't. We'll get to those in later days. But this one does follow a nice pattern. If we look here, every time this number changes, when we went from 3 to 6, and 6 to 9, and 9 to 12, and 12 to 15, every time it was going up by 3, up by 3, up by 3, up by 3. And the nice thing is, 0 fits in that pattern too. So we can work our way back by 3s. 15 to 12, 12 to 9, 9 to 6, 6 to 3, 3 to 0. So that means the 0 actually fits nicely in this pattern. That is our friend. They won't always, but this time it did. So that was nice. And that means that that pattern fits. Well, here, to get from 4 to 6, we did plus 2. 6 to 8, we did plus 2. 8 to 12, we did plus 2. 10 to 12, we did plus 2. So this is a nice steady pattern, which means this will have been plus 2 as well. So what number must have been here if adding 2 to it gives you 4? And you can just count on your fingers. You can subtract. Lots of ways to do this. But I know that the answer here must have been 2. Right? 2, 4, 6, 8, 10, 12. Nice, easy pattern. And so what we then know is this is what the 0 spot on this table would have been. And since that's what the 0 spot on this table would have been, then we can say b is equal to 2. The initial value is 2. Now, a note. The table doesn't have to work out so that you only have to go back in the pattern once. This could have started at 9. You know, this table could have gone now 9, 12, 15, and what was with 9? 8, 10, and 12. And you might have had to say, okay, we're going by 3s here. So I'm going to go by 3, and that'll give me 6. And then by 3 again, that'll give me 3. And then by 3 again, and that'll give me 0. And I could have said, okay, well, here I'm going by 2s. And I might rewrite the table because it's never a bad idea to give yourself space. So I could have said, okay, let's make this big, x and y. And yeah, 3 less than 9 would have been 6. 3 less than 6 would have been 3, and 3 less than that would have been 0. It is possible to have to work your way back. A few places, and if you have to work your way back a few places, that's okay too. It'll come with practice. So I suppose I should use a different color. And if you have to work back a few steps, that's okay. That is not the end of the world either. So with that in mind, you can practice that with this. And let's practice one together, just so we see how this works. I think this is set up that you only ever have to work once back in the pattern because we're still just learning. We will get to trickier ones as we go. So we could grab this table here. I could maybe come to the side here. And we could look at it and say, okay. And over here, we are going up by 6, up by 6 again, up by 6 again, and so on and so forth. And here, from 1 to 0, that's going down by 1 again. So these numbers actually keep getting smaller and smaller. So if we wanted to have 0 here, which it looks like that works nicely, because that would be up 6 again, then what number would have to go here? Because these keep getting smaller by 1. -3, -2, -1, 0, 1. This one would have to be 2. And so we'd be able to say b is equal to 2. Let's see if we got that right. We can come over here and check. Initial value is 2. Check the answer. Yeah, b is 2. We done good.